Hello and welcome to another video. In this one, we're talking about lazy imports again, and specifically a terrible hack that I have put together. But before that, we need to go back to PyCon US this year, and I was sitting in basically the last slot before the conference is over, which is always the steering council panel, where a bunch of, users submitted questions are asked and the steering council answers them. And this specific question came up. And as soon as it showed up on the screen, I knew I was going to be hyper-focusing on something terrible for a few hours as I was thoroughly nerd-sniped by this. Is PEP 810 lazy imports planned to be backported to Python less than 3.15, possibly in Python 3.10? And obviously the answer to this was, haha, no, absolutely not. The way Python's release structure works is features are never, backported to minor versions. Obviously there were some exceptions in Python 2.7, and you could argue that the garbage collector change in 3.14 was similar as well. But generally, large features are never backported to versions of Python once they've reached beta, actually, not even after beta, although there's been exceptions to that as well. So no, absolutely not. This was not going to be backported. This will only land in Python 3.15, but I thought, I bet I could make this work. And if you're familiar with things that I've done in the past, well, I'll actually show that at the end. Well, no, I'll show right now. Actually, can I even show right now? I can't. I don't think I have Python 2. I guess I could do it through Docker. But anyway, in the past, I've backported f-string support to Python 2 and breakpoint to things less than Python 3.7 and a few other things like that. But I thought, you know what? This would be a fun little challenge. I don't particularly think, well, I think lazy imports are kind of neat, but I'm still not completely sold on the concept on the whole. I guess I should talk about what lazy imports are in the first place with a small example, and then we'll use that small example to run it in versions of Python that are older than Python 3.15. Also note that Python 3.15 isn't quite out yet. I'm currently running beta 1. I believe beta 3 just landed. I just haven't updated yet. But you can get this through Dead Snakes if you're on Ubuntu, which I maintain. But anyway, let me show a small example. What's a good example? I guess we'll just do a program that uses async IO. If doubler name equals main. Why? Why did that seem so foreign to write, even though I've written it a million times? Main function, and let's just do an async def. Hello? Hello world. Obviously this is kind of a silly example. Import async IO, and actually we can even do from async IO import run, and then run hello. So this is a very simple program, and if we look at its import time alone, I guess we can do siteless mode so we get the fastest version of this. Best of and 10 this. It takes, you know, 40.045-ish seconds to import. If we take this, we're running in 3.15, yeah. If we take this and we make it a lazy import, I haven't implemented the syntax highlighting for it yet, but I'll get that at some point. You can see that the bulk of this import time is that async IO import. And so you may imagine taking this and having like a help message here that shows that you might want the help message to appear faster and avoid this bulky import until it's needed. Obviously, we can also show that it still works in Python 3.15, but this is kind of the point of lazy imports. You can also use them if you have typing only things for annotations, or to avoid circular imports in some cases. But I covered more of that in the lazy imports video. This one is about the terrible thing that I made, which is that we can make a virtual env. Let's use the example. What did they say? Python 3.10? Yeah. Python 3.10. And if we try and run that same module, we're going to get a syntax error. Syntax error, invalid syntax, because obviously 3.10 doesn't support lazy imports. until we do this terrible thing. We first put a special comment on the top of this file. This is now a load-bearing comment. This is not all we need. We also need to pip install future lazy imports, which is the terrible thing that I made. And now if we run this, you see it works. And in fact, it has similar characteristics to we can't do siteless mode because we actually need the site package. It has similar characteristics to what we had before, where you know, it's taking 0.021 seconds, and if we had removed the lazy here, you can see it would take 0.044 seconds. So you can see that the import is being executed lazily, and the trick of this is the the pre-processing and this load-bearing comment here. But it works. Now, this is kind of what it's doing behind the scenes. So what this little comment here at the top of the file is it's an encoding statement. It says, this file is not UTF-8. It's actually this future lazy imports encoding. So decode my source bytes using this encoding, and then evaluate the code. This used to be really common in Python 2, where you would actually want your code to be UTF-8 because the default encoding was US ASCII. And so, yeah, that's what this does. You can look at the translated source code by doing this. Oh, except that I have broken the package. You can see where I copied it from. Let's, I never actually tried this, did I? Yeah, I didn't write any tests for this. I just kind of threw it together. There we go. Wow, okay, I guess I'll fix that before I upload the video, which means I have very limited time to do that. But what it does is it does some source transformation. So the first time it sees a lazy import, it adds a little bit of preamble code. It's damnedest to keep everything on the same line numbers that it originally was. That way, if you have stack traces, you'll still see the same line numbers here. But it basically imports a bunch of its helper functions, and yeah, it's always going to eagerly import functools and future lazy imports and the modules that this depends on. So argparse, tokenize RT, RE, and a few others are always going to get imported, but it's a silly idea. It's, you know, I wanted to see, is it possible, not is this a good idea that you should use in production, which I would not recommend using this, even though it is functional and it mostly seems to work. But anyway, so preamble code, a few things here that are useful. Lazy P is kind of like the, if we look in Python 3.15, lazy import async IO, and then print globals async IO. That's kind of the equivalent to this lazy import type. That's what this lazy P is. Lazy R is the resolve function. So the way future lazy imports works is it's not the same as how the actual lazy imports works. It adds a little preamble to the beginning of each function that makes this name no longer lazily imported. So it messes with globals and injects the actual import into the namespace. The way it works with actual lazy imports is the load global bytecode. The instruction will look for lazy things and then resolve them then, but we don't have the ability to modify bytecode. Well, I guess I could have done this by jitting all the bytecode and then swapping it out, but this felt more true to the idea of a source rewrite and makes it a little bit easier to understand what's going on. But anyway, at the beginning of the function of anything that references a lazy name, it'll try and resolve, or it'll eagerly resolve this name, and then this will be available the rest of the function. There's also a little strangeness here in that all of these names now get prefixed with this lazy thing. This is for another reason, which is that module level getattr needs to still work. Obviously, I a little over-engineered this, but module level getattr sort of needs to work. So if you had done like I don't know, return something like this. I wanted module level getAttr to work for lazy things and also for imports to work for lazy things. And so the code needs to do some special stuff to still support this and still support lazily importing things from this. So if we did from t import run, this should resolve the async IO run function. If we look at module here, and it'll still have to go through the laziness here. And so that's kind of what that special double-ended getAttr does. So if we look at, yeah, so it's renamed that module level getAttr. It's injected its own module level getAttr. And so that's why these have a different name here. It's so that this can know to resolve things properly and stick them into the namespace after the fact. But beyond that, it mostly runs this normal Python code. There's a few edge cases where it can't preserve stack traces. For instance, if you have a block statement at the beginning of the function, then it can't inject code before this, and it can't inject code on this line either, or it's a syntax error, so it actually has to put a new line here. So that'll break any stack trace for any line further in this file, but it tries pretty hard to not do that, so I don't know. It's jank. I didn't try and make it perfect, I just kind of tried to make it work for some of the basic edge cases, and you know. This is the stupid thing. But anyway, if you want to play around with it, you can pip install future lazy imports. I would not recommend using it. But my future f strings is you know, a similar idea, and unfortunately got to millions of downloads a month. I don't think it's quite at 1 million downloads anymore per month, but why is that taking so long to load? Maybe this is a better one. It's been downloaded 47, I mean the text is really small, but 47 million times, and about a million in the last 30 days. I don't know why PyPI stats is not loading, but anyway, please don't use this. It's a little jank, but it kind of works, which is kind of fun. Anyway, hopefully you found this interesting. Oh, I should talk about how it works. I didn't even do that part. I've actually talked about how future f strings works in another video, and it's the same way in this one. So it registers an encoding. The way it does that is via a PTH file. This is actually the last version that PTH files will sort of be used for this. In the future, start files will do the same idea, but since I'm not targeting 3.15, I don't really need to worry about start files, but it injects this PTH file here. And inside this PTH file, it has an import, so the code execution mode is triggered, and then an exec that tries to call future lazy imports.register, which is the thing that sets up that encoding that we talked about. So you know, you can actually do like hello bytestring.decode future lazy imports, and it will actually transform the source code here. Like if you did lazy import sys, you can see that it has transformed the source code here to do the preamble and other stuff here. So that's the encoding that it registers. And then at startup, Python checks the source coding in here and then decodes the source before compiling it. But yeah, I did it. I did a terrible thing. There's some stuff that probably doesn't work. I know that I didn't instrument lambdas, so they don't have like, I didn't think about trying to inject code into them, so I was just like, whatever. It's intentionally bad, but kind of was just more to prove a point. I'm pretty sure it also doesn't work with anything that's eagerly evaluated. So if I tried to use run at the module scope here, I'm pretty sure it doesn't work. I'm kind of curious what happens if I do this. I'm pretty sure it'll just name error. Yeah. Which kind of makes sense. Like I didn't make, like the whole point of lazy is to not evaluate at the module scope. Type annotations might not work unless you use future annotations. I I don't know. There's surely a lot more stuff that's broken, but I kind of wanted to get the base demo working, and that was good enough for me. Anyway, hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.